The B-21 Raider represents the cutting edge in strategic bomber technology, designed specifically to address the evolving challenges of modern warfare where the ability to penetrate increasingly sophisticated air defenses is paramount. Its development is rooted in decades of experience with stealth and long-range strike capabilities, incorporating the latest advances in aerodynamics, materials science, propulsion, and electronic warfare. At the heart of the B-21's design is its stealth capability, which is not just about avoiding radar detection, but about reducing signatures across a range of detection methods, including infrared and electromagnetic emissions. The aircraft's shape, resembling a flying wing without vertical tail fins or other protrusions, is purpose-built to scatter radar waves, drastically lowering its radar cross-section. This flying wing form minimizes edges and angles that can reflect radar signals back to their source, making the aircraft much harder to detect by enemy radar systems. The surface of the B-21 is covered in advanced composite materials, some embedded with radar-absorbing substances. These materials are crucial in reducing the radar returns from the aircraft, and at the same time contribute to overall weight savings compared to traditional metal airframes. Lighter weight translates directly into longer range and increased payload capacity, enabling the bomber to reach distant targets and carry a variety of weapons internally without compromising stealth. The smooth exterior is carefully maintained to prevent seams, gaps, or irregularities that might compromise the low observable characteristics of the aircraft. Maintenance of these surfaces is complex and demands specialized facilities and procedures to ensure the stealth coatings remain intact and effective over time. Beyond radar stealth, the B-21 incorporates thermal management features to reduce its infrared signature. The engines, which are powerful but designed for fuel efficiency, have inlet ducts shaped to block direct line-of-sight access to the hot compressor blades, which are one of the strongest infrared sources. Exhaust gases are cooled and dispersed in ways that minimize heat concentration, and nozzles are designed to mix exhaust with ambient air to further reduce heat signature. These infrared reduction techniques make it significantly more difficult for heat-seeking missiles and sensors to detect and track the bomber, especially during long-range missions where exposure times can be lengthy. Inside the aircraft, a sophisticated avionics suite integrates multiple sensor inputs into a unified operational picture for the crew. These sensors include radar warning receivers that pick up emissions from enemy radars, electronic support measures that can identify signals across the electromagnetic spectrum, and potentially active electronically scanned array radar systems for navigation and target identification that operate at low power to preserve stealth. The data from these sensors is processed by advanced algorithms that filter out irrelevant signals and prioritize threats, giving the crew timely and accurate situational awareness even in heavily contested airspace. In addition to passive sensing, the B-21 carries an active electronic warfare capability that can jam or deceive enemy radar and communication systems. This means the aircraft can not only evade detection but can actively disrupt and confuse enemy air defenses, creating opportunities for itself and allied forces to operate with less risk. These electronic countermeasures can produce false targets, suppress radar emissions, and interfere with missile guidance systems, increasing the bomber's survivability during penetration missions. Communications systems on the B-21 are engineered for both security and stealth. The bomber uses encrypted communication links that are low probability of intercept, minimizing the chance that transmissions can be detected or intercepted by adversaries. This is crucial for coordinating complex strike missions over long distances, where real-time updates and retargeting may be necessary. The aircraft can communicate securely with command centers and other assets while maintaining its low observable profile. One of the defining features of the B-21 is its internal weapons bays. Carrying weapons internally rather than on external hardpoints preserves the aircraft's stealth profile. These bays are large enough and versatile enough to accommodate a wide variety of precision-guided munitions. They are designed to be modular, so the bomber can carry different combinations of conventional or nuclear weapons depending on the mission. The doors of these bays open and close quickly and in a manner that maintains radar stealth, minimizing the risk of detection during weapon deployment. The range and endurance of the B-21 are key to its strategic value. It is capable of flying very long missions without the need for forward basing, a critical advantage when operating in environments where friendly bases may be vulnerable or unavailable. The aerodynamic efficiency of the design, combined with advanced propulsion systems, allows the bomber to travel intercontinental distances. Aerial refueling capabilities extend this range further, enabling missions that can span the globe. The refueling process itself is designed to be as stealthy and low exposure as possible to avoid detection during these vulnerable periods. Operating the B-21 requires a highly skilled crew, trained extensively in managing complex avionics, electronic warfare systems, and navigation in contested airspace. Human factors and ergonomics have been considered carefully to ensure that the crew receives clear, prioritized information that supports rapid decision-making. Advanced simulation environments help crews prepare for a variety of mission scenarios, including evading modern integrated air defense systems. The training also emphasizes stealth preservation, communication discipline, and coordinated operations with other military platforms. The development of the B-21 has leveraged modern digital engineering techniques. Rather than relying solely on physical prototypes, engineers build detailed digital twins of the aircraft to simulate performance under various conditions, test new systems, and identify potential issues early in the design process. This digital approach accelerates development timelines, reduces costs, and supports ongoing upgrades. Manufacturing incorporates precision robotics and automated quality control, ensuring each aircraft meets strict standards for stealth and performance. Environmental controls in manufacturing facilities protect sensitive materials and coatings, ensuring their longevity. Maintaining the B-21 in operational condition involves specialized procedures to preserve stealth features and keep electronic systems at peak performance. Ground crews use advanced diagnostic tools to quickly identify any system degradations or damage, allowing for efficient repair and turnaround. Maintenance of radar-absorbent coatings requires clean environments and skilled technicians, as any damage or contamination can increase detectability. The sustainment infrastructure includes climate-controlled hangars and secure storage for critical components. Strategically, the B-21 is intended to provide a deterrent capability as well as an offensive option. Its ability to penetrate sophisticated air defenses ensures that key targets can be held at risk, complicating adversary planning and response. The design anticipates future advancements in detection and interception technologies, with modular systems that can be upgraded over time. This future-proofing means the B-21 will remain relevant even as new threats emerge, such as improvements in radar technology, missile seekers, or cyber-electronic warfare. The B-21 Raider is a highly advanced, stealth-optimized strategic bomber designed for global reach and survivability against modern and future air defense systems. It integrates the latest materials, stealth design principles, sensor fusion, electronic warfare, and modular payload capabilities to provide a flexible and enduring platform. Its development and operational concepts reflect the increasing complexity of modern conflict environments and the need for strike platforms that can operate effectively in contested airspace with minimal risk of detection or interception. This aircraft embodies a multi-dimensional approach to stealth and operational effectiveness, incorporating innovations across aerodynamics, materials science, avionics, and mission systems, all focused on maintaining the ability to project power and deliver precision strikes anywhere in the world.